Okay, I'm going to solve this question, which is question number 3 of the final exam of term 211, continued, okay? So it says here, using the minimum number of adders and additional gates, of course, design a comparator circuit that takes two signed 2-bit numbers, X and Y, and produces 3 outputs equal, less than, and greater than. Okay. Okay, so we have we would like to design a comparator using a subtractor. Okay, so we have X and we have Y. Okay, and we would like to know whether X is less than Y. For example, then what to do? We can move Y to the other side, and this implies that X minus Y is less than 0. Okay, if it is less than 0, if the difference here is less than 0, then what does it imply? It implies that X is less than Y. Okay, or you can say that Y is greater than X. Okay. However, we must avoid overflow, because if there is an overflow, then this operation here may not be valid. Okay, so we have to make sure that our circuit does not overflow. Okay, our subtractor does not overflow. So we have to find out X minus Y, the minimum and the maximum, and then we have to sign extend our X and Y such that the circuit never overflows. Okay. Okay, so what is the difference? Okay, let me call the output of the comparator. Let me call it S. Okay, the output of the subtractor. Let me call it S. Okay, which equals X minus Y. Right. So the maximum of X or S is equal to the maximum of X minus the minimum of Y, right? And this equals, now X and Y are 2-bit, right? 2-bit unsigned. This is very small, okay? If it is 2-bit, then it ranges from -2 all the way to +1, okay? So this is the minimum and this is maximum, all right? And this equals to the maximum of X, which is 1, minus the minimum of Y, which is -2. Okay, so this is going to be +2, and that equals +3. Okay, so this is the maximum of X. S. The minimum of S is the minimum of X minus the maximum of Y. Right, and that equals to what? The minimum of X is -2 minus the maximum of Y, which is +1. So that is -3. Okay, so we need our circuit to range from, or our S to range from -3 to +3, which is covered by the range -4 to +3. Okay, which is basically, which requires 3-bit. Okay, so your S needs to be S is 3-bit to avoid overflow, of course. All right, so we need to extend or sign extend X and Y to be 3-bit as well. So S is going to be X2, I'm sorry, it's X1, X1, X0. Okay, this is the sign extension of X by 1-bit, okay, minus Y, which is Y1, Y2, Y0, I'm sorry, Y1, Y0. So this is the sign extension of the Y, all right? And we know that you can change this subtraction to addition using 2's complement by complementing this and adding a 1, right? Okay, so if you do that, then this is going to be X1, X1, X0. And you are adding this with Y1 complement y0 complement plus 1. Okay, so this is your circuit basically. First, that you need to calculate the difference. Okay, so you have a full adder in which the carry in is 1. Okay, this is the carry in, this is a full adder. And you're adding what? You're adding y0 complement with x0. And then you have another full adder. You're adding y1 complement with x1. Okay, of course, together with the carry out from the previous stage. Okay, and also the final full adder for the third bit for y1 complement and x1. Okay, together with the carry out from the previous stage. So this is your S0, S1, and S2. Okay. Now your less than, if you want to, so here, less than, let's say that, let's define less than to be 1 if x is less than y. So this means that x minus y, which is the difference, which is s, is less than 0. And when does this happen? When the sign bit is 1. So this is your sign bit here. Okay, so this is equal to less than. Okay, you notice that your circuit ranges from -3 to +3. It cannot reach -4. Okay, so it cannot reach -4. Yeah, so basically to detect equality, what we need to do, okay, is basically just since your circuit, since 100, which is -4, is not among the numbers that are reached by your circuit, so we don't have to worry about -4 occurring in your input. Okay, so in order to detect a 0 for S, we need to check only S0, bit S0, and S1. Okay, if we basically OR these, or NOR these, in fact, okay, we are going to get the equality. Why didn't we take S2 together with them? Because basically when S2 is 0, it means when S0 and S1 are 0, okay, S2 will be 0 also. Okay, it will be 0 because 100 is not part of the circuit output. Okay, if you have 0 in S0 and 0 in S1, then S2 is also 0 for this circuit. Okay, you cannot have 100 as an output of the circuit. So this detects equality, and to detect greater than is nothing but equal. This is greater than, okay, equal, ORed with, or NORed with, less than. All right, NORed with, less than. Okay, I'm going to stop here, and we continue some other time.